Welcome to The Explainer. I am absolutely thrilled you're here today because, honestly, we are looking at a truly massive breakthrough. We're going to unpack DeepMind's May 2026 research paper introducing the AI Co-mathematician. We're talking about a system that fundamentally transforms artificial intelligence from being just, a basic calculator or a clever search engine into a genuine collaborative research partner. So let's unpack exactly how this multi-agent technology works, how it's being used by real mathematicians right now, and what the data tells us about its groundbreaking performance.
Now, to really wrap our heads around the impact of this release, I want you to imagine sitting at the Stanford Symposium on the Future of Mathematics in 2026 and hearing this exact summary: Space aliens landing. No joke, that's not from a sci-fi movie. That is a direct quote capturing the shockwaves currently rippling through the academic community. We aren't just talking about incremental progress here. We are literally setting the stage for a massive paradigm shift in how human knowledge is created.
Okay, let's dive right into this. Section 1, the hidden mess of math beyond the chalkboard. To appreciate the solution, we first need to understand the problem. The public usually sees math as these pristine, polished proofs presented in journals or on chalkboards. But the day-to-day reality of mathematical research, it's deeply exploratory and, frankly, it's a huge mess. Up until now, we've basically had standard AI chat interfaces. And sure, they're incredibly powerful, but they're transient. They treat inputs as isolated queries, they easily get confused during long projects, and they rely entirely on you, the human, to act as the manual connective tissue. But the messy reality of math requires something completely different. It requires long-term, stateful orchestration. We're talking about tracking branching hypotheses over days or weeks, managing uncertainty, and keeping a rigorous record of dead ends. The transient chat models we're used to, they simply fail to support this kind of genuine, long-term discovery.
Which brings us to Section 2, Enter the AI Co-mathematician, Stateful Orchestration.
So, this is DeepMind's direct answer to that missing dimension we just talked about. They realize that to truly accelerate discovery, the AI has to handle the messy orchestration, not just answer isolated questions. Enter the AI Co-mathematician. It's a multi-agent workbench built on Gemini language models, and the absolute key phrase here is multi-agent. This isn't just a single chatbot you talk to. It's an entire team of specialized agents designed to mirror human collaborative workflows. It allows for asynchronous, stateful collaboration. Basically, that means the AI team is working in the background on your open-ended research and actually remembering the context of the entire project as it goes.
Let's move on to Section 3, How the Agents Collaborate, the Agent Hierarchy.
Let's actually look under the hood right now to see how this system divides and conquers incredibly complex research problems. It's all about managing cognitive load through progressive disclosure. High-level strategy is completely separated from low-level execution. So in step 1, you, the human, talk to the project coordinator agent to formalize your high-level goals. Then, in step 2, that coordinator delegates to workstream coordinators who manage specific tasks. And finally, in step 3, those coordinators deploy specialized subagents. These are the workers in the trenches. They're the ones scouring the literature, writing Python code to test theories, and utilizing Gemini DeepThink for the actual theorem proving. It's a highly organized digital team. And here is the absolute kicker: what this entire hierarchy actually produces. Instead of transient chat logs that just vanish when you close your browser, the system outputs rigorous, native mathematical artifacts. It creates a living, working paper compiled in LaTeX, which is the gold standard formatting language for mathematicians. It features inline visualizations, margin annotations linking right back to sources, and even independent reviewer agents that verify the math before it's finalized. It preserves the entire history of the exploration. It literally treats even the failed dead ends as permanent, highly valuable outcomes.
All right, Section 4, Real-World Human in the Loop, Solving the Korovka Problem.
Now, theory is great and all, but what actually happens when world-class mathematicians get their hands on this workbench? The big question was, can an AI help solve an open problem from the Korovka notebook? Specifically, this was the monumental challenge faced by Oxford mathematician Mark Lackenby regarding problem 21.10. For context, this is a highly complex open question involving topology and group theory. And this right here is the exact synergy that makes this so revolutionary. The AI didn't just flawlessly solve it on the first try. Instead, the AI's specialized agents proposed a proof that was, as Lackenby described it, really, really clever, but ultimately flawed. However, the heuristic guesswork was so brilliant that the human mathematician was able to easily spot the flaw, steer the AI in the right direction, and fix it.
Then the AI took over again and compiled the final rigorous latex proof. It's literally like having a brilliant but overly eager grad student doing the heavy lifting, leading to true 50-50 co-authorship. And Lackenby wasn't the only one experiencing this. G. Barretsey used it in symmetric power representations to establish proofs for Stirling coefficients using computational enumerations. And S. Ryzhikov, working in Hamiltonian systems, specifically noted that the system saved an entire week of exploratory work. Why? Because the agents helped him reach dead ends faster, clearing the path to an elegant proof. It doesn't just do math, it fundamentally optimizes the researcher's time.
Next up, Section 5, Crushing the AI Benchmarks, Orchestration versus Scale. We've seen the qualitative success, but objective data brilliantly illustrates why this specific multi-agent design is vastly outperforming the rest of the industry's focus on raw model scale. Just look at the highly rigorous Frontier Math Tier 4 benchmark. The base model, Gemini 3.1 Pro, scores 19%. GPT 5.5 Pro, a next-generation foundation model relying strictly on raw scale, hits 39.6%. But the AI Co-mathematician, powered by that same base Gemini model but using multi-agent orchestration, it scores an unprecedented 48%. It correctly solved 23 out of 48 research-level problems, establishing a massive new high score among all AI systems evaluated. And this benchmark success is exactly why the Latent Space newsletter summarized the magnitude of the achievement with this quote. They called it the most consequential science result of the week. It succeeds because it natively designs its workflow around the actual abstractions and working paper realities of professional mathematics, rather than just trying to build a bigger chatbot. It's a total game changer.
Finally, let's look at Section 6, Space Aliens and Future Work. The community reacts.
So, how are the mathematics and AI communities actually reacting to this release online? We want to impartially report the facts here. Community sentiment data pulled from Dig AI Analytics, which encompasses X, Reddit, and Mastodon, shows the reaction is overwhelmingly positive at 88.5%. There's incredibly high praise for the stateful orchestration and those real-world case studies we reviewed. However, there is a distinct 11.5% portion of critical feedback we definitely need to look at. Based on the source material from X and Reddit, this 11.5% critique primarily stems from a few key areas. First off, there is significant frustration that the workbench is currently restricted to limited internal testing for select professionals, and many are really hoping for a public or open source release soon. Additionally, there is a noted existential anxiety among some researchers. They worry that as these agentic systems improve, humans might eventually become a performance liability in the generation of formal proofs. We are simply laying out what the data shows the community is feeling right now as they process this massive technological leap. So I want to leave you with a final provocative thought. If AI can now orchestrate the messy, highly complex process of mathematical discovery, if it can manage uncertainty, track branching hypotheses, and compile living, working papers, what scientific field will it co-author next? Physics? Genomics? The implications of agentic orchestration stretch far, far beyond the chalkboard. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll see you next time.